Good morning guys. We're back at it again with another video. So exciting times because the HVAC system is now actually up and running right now. Very exciting. Keep this place nice and chilly in the summertime and warm in the wintertime. So we've got the entire cavalry here today, and they're going to explain the Mitsubishi system and some of the major reasons why we're doing it. But we got
Devin Simpson with Williamson's Heating and Cooling.
Rob Williamson, owner of Williamson's Heating and Cooling.
Jim Clark, Mitsubishi Electric.
And I'm Rick Zard with Ferguson HVAC.
So you're the first one that came out here, and so I made the video asking for help, and a guy from Mitsubishi actually got in contact with me and got me in touch with you guys. And so you've been working in the HVAC field for quite some time. You don't have to say how many years.
43, I won't say though.
But you've been working in the field for quite some time, and you've been working with the Mitsubishi equipment or specializing in it for about how many years now?
About 12 years we've been working on it. Since it's actually became UL approved into the United States, that's when we started using the Mitsubishi product.
And what do you like about it as someone that has been installing the equipment for some time as opposed to other systems?
I like the reliability of it, the functionality of it, the ease of installation. You know, it's funny because we put a lot of unitary systems in. That's kind of the standard, you know, furnace in the closet, unit sitting outside, and people are happy, they like it. But when we put a Mitsubishi system in, all I get is people saying, this thing's amazing. It's so quiet, so efficient. It covers the areas perfectly. It's true zoning in every single room. So if you're not in it, you don't use it. You know, if you're in your master bedroom, you keep it at 70 degrees. The rest of the house could be at all different temperatures or turned off. So it's a beautiful piece of machinery. And it's the most reliable piece of machinery I've had the privilege to install and service. So
you're down here, you're in Benson, so you're based out of Tucson, but you've also done work all the way down towards Bisbee as well.
Oh yeah.
So you guys cover quite a wide range. So if you need someone that is obviously specialized with the Mitsubishi equipment, contact
Rob Williamson and Williamson's Heating and Cooling.
CoolTucson.com?
Yep, www.cooltucson.com.
I'll put all that information down below. These guys were highly professional, showed up on time, cleaned up after yourselves.
That's right.
I don't feel like I set the bar too high, but I feel like those are standard things, and these guys absolutely nailed it with basically running all their line sets and all the duct work. Everything was done very, very well, and I'm very pleased with the work that you guys have done. And now, Jim.
I just got done sweeping the floor for Williamson.
Thank you. Thank you.
Very welcome. No, you know, it's so wonderful to have such great contractors installing our equipment. They're meticulous. They take care of our customers, and really, you know, it is our customers as well as it's theirs. We take a lot of pride, and the pride that we have with Williamson doing it is wonderful. And that's the other thing is we also have distribution. The guys that give us the support, you know, the contractor support, the teaching of the product, you know, if there's a problem or an issue, these are the guys that get into the field to help. Not very often do they have to ever help Williamsons because they're so well trained. But there are times that, you know, when you're first getting into the equipment, that you need to just have somebody hold your hand to tell you you're doing it right.
So you don't get a call from and talk to this guy. He's the complaint department.
I am Mitsubishi's complaint department.
So you work specifically with Ferguson, but you guys are obviously a major distributor of Mitsubishi.
Correct. I work directly for Ferguson. I'm what they call their DSG service tech. For Mitsubishi, DSG stands for Diamond Service Group. All it means is that I've been working with Mitsubishi for probably about the last 10 years. I've gone through all of their trainings, and they just kind of give me the stamp of approval to believe that I know what I'm talking about.
That's good. And you're mentioning that you've been to obviously a lot of jobs before.
Yes,
and,
I've been.
And how would you rate, like, look at those straight line sets over there.
No,
how would you rate the work that they did in here?
I have to say, as far as installs go with this, it's definitely a 10. I've been to, as you said, many different job sites, and just the amount of time that it took to put in to run those lines like that, to where everything's nice and even. The way the installation actually goes all the way up to all the fittings. I mean, just the small, meticulous things that they have just knocked it out of the park. I'm extremely happy to see our products installed in this manner.
So we've got Devin here, who was the lead foreman on the job and made all the magic happen here. So we're starting up the system here for the first time. Everything seems to work all right. Nothing blew up, which would have been my fault. But nothing blew up, so we're good.
That's right. So what we got here is the MXZ. It's actually a 3.5 ton multi-zone system. We just got everything installed, and right now we're actually starting the system up just to see how everything's operation. We just got done doing a pressure test. We got everything up to 650 PSI. We let that hold for about roughly 3 hours. We had 0 pressure drop on it. So what we did then is we ended up doing a vac system on it. We actually did a triple evacuation. We got our microns down to 290, and we were able to do a rise test. Everything seemed to pass with that. We added our additional refrigerant, which is 8 pounds of refrigerant, and now we just finally started the system up. So what we're doing now is we're going to be checking amp draws and actually dialing the system in with the MNet tool, which is going to be able to actually make this system run at its peak performance.
Now, one thing I gotta say, working in the field as an apprentice electrician for such a long time, with how HVAC systems are, this is a totally different animal. This is, I would say, what you guys do with this type of stuff is far more complicated than anything that I've ever done. So this is obviously, you know, very specialized knowledge, and you've got some great tools to obviously make that happen.
That's correct. And now one of the special things about these systems is not like a conventional system that you're going to see in everybody's house. There's a lot more components to it. There's a lot more software into it. To even be able to install these systems, we all have to get factory trained through Mitsubishi, just so that we know exactly what's going on with these systems. Some of the main components with this unit that makes it so special is it's not just a single stage or a 2-stage system. With this compressor, we actually have multiple hundreds of different stages on this compressor, so it's going to be able to ramp up and down just depending on the demand that is required in the house. With that being said, we're going to be able to slowly start this system. So now when this unit starts up, you're not going to see any of your lights dimming or anything else like that. It's just going to slowly go up to just what we need, and then it's going to slowly back itself down to where it's actually reached temperature inside and will eventually shut down. With that being said, when we're not peaking the meter, what we call it is when we first fire up a system, that's when you're going to have your most amps drawn. With this system starting off slowly, we're going to slowly raise the amps throughout the house, which means, again, we're not going to peak anything, have lights dimming.
This is a lot of stuff going on here.
There is a lot of things going on.
So for those of you that thought I could do this myself, this is not exactly a DIY.
No, this is not anybody could do this. Again, like I said, you need to be factory trained to be able to actually do the system properly. For our company ourselves, which is Williamson's Heating and Cooling, we're actually Diamond Elite dealers, meaning that we've gone through the schooling, we've done the systems enough to where we know how they operate. We have a service department that knows how to work on the systems, and we have a great installation department to give you a great product at the very end.
So now we got the nerd here. He's got the computer out.
In all of our system, the outdoor unit, the control board right here, it controls everything. It takes every single demand that the indoor unit has, and it uses this algorithm to ramp up or ramp down the compressor and the fan motors in order to achieve what we're asking for.
So that's with the Mitsubishi system, with the VRF system,
yes.
It's for variable refrigerant flow. So instead of the system just cranking on and blowing really hard at periodic times throughout the day, it's only turning it on, well, it's actually, the fans are running 24/7.
Correct.
So how does that kind of work there?
So we have the fans running in 24/7 for a couple of reasons. One, it's actually more efficient because we actually have very low amperage DC brushless motors on them. And so basically by keeping the fan going, we're able to actually mix the air up, because a lot of times when people have issues with their heating or cooling system, first thing you notice is hot spots or cold spots. So by mixing the air up, you're going to actually get a more even temperature throughout the house. Another thing on what we're trying to achieve here is with your normal unitary system, you think about it as a light switch. You're either on or off. There is no in between. So when we size our house for, you know, the hottest part of the summer, it's not always the hottest part of the summer. So when we're not in that kind of temperature, we're wasting a lot of energy. With this system, it kind of fills how far away we are from set point, and it only ramps up as far as we need to. So instead of it being a 3 or 4 ton that we need, or that it was sized as, we only need 1.5 tons, so it's going to ramp way, way low and save a lot of energy. And the byproduct of that is because, you know, when you're using a unitary unit, you're waiting for the temperature to go up 3 degrees, then we're turning it on, and then we're bringing it back down. And then as soon as we reach temperature, we shut off, and it starts rising back up. See, the problem is that we constantly have a heat load in our house. So by just chasing it, by turning it on, when we go up above our set temperature and chasing down, that's good, it's always worked, but the problem is when we turn off, because that heat load's still there, so it keeps continuing to rise. Versus with this, what it'll do is temperature goes up, it'll ramp up, and then it'll bring it down. And as soon as it starts getting down, and we're getting towards set temperature, the compressor is going to start ramping down until the heat starts going up, and it's going to ramp up a little bit more, and it's going to kind of balance out. It costs a lot more money and a lot more energy to change a temperature than to maintain the temperature.
Right.
So by doing that, we're able to save a lot of energy. And then the better part about it is that because we don't have those fluctuations, it's actually more comfortable, because we're not running into, you know, 2 or 3 degree off, you know, throughout the day every couple minutes. So.
Okay, so now we're inside the home. Now we were just outside at the condenser, kind of explaining how that system works. So now, like I said, we have a multi-zone system throughout the whole house. And how this is working is we're taking that refrigerant from the compressor, going to this branch controller. So we're taking that refrigerant from the compressor, and we actually have all of our manifolds built into this box. And each line set is going to a different air handler throughout the house. And then if we step down here, this is going to be one of our, basically it's like a soffit attic mount, low static air handler system. So with the Mitsubishi product, they have multiple different kind of air handlers that you could actually install. They have wall mounted units. They also have ceiling cassette units that they actually just sit flush with your ceiling and blow out the air 4 different directions. Or they have a one-way system where we're just kind of blowing air one direction. Now with this particular ducted unit, the advantages of this one is we can now send air to multiple rooms. So this one here is actually feeding the master bedroom and bathroom. So now we're going to be able to have ducting going to the master closet or bathroom. We're going to be pulling our return air from this direction here, and then we're also dumping another supply into the master bedroom itself.
So obviously if this was a Unitarian system, you'd have ductwork running from obviously a central location, but you wouldn't be able to really kind of control the temperature in here, obviously, as well as you would like to.
Exactly. So now being able to have this multi-zone, just maintaining the master bedroom and bathroom itself, we got its own thermostat, so now we could put it whatever temperature we want it to be at, which works great for especially at nighttime. You know, like personally, I like to sleep when it's nice and cold. Now I could bring this temperature down to 65 degrees in here, let the rest of the house be at 78, 80 degrees, and I could be nice and comfortable. I'm not having to heat and cool the entire house, just the one room that I'm in. Okay, so now as you're looking at this system, you see that we're in a living space now. Eventually, once we have drywall up and ceilings in and everything else like that, most conventional systems, we end up having to put extra auxiliary drain pans underneath the system so that if it ever does happen to have a condensate backup, a freeze up issue, that's going to be able to catch that water and take it outside. With this particular system, we don't need any of that extra stuff. It has built-in safeties. It's got a condensate pump system on it to where if we need to use a pump to pump the water out, we could do so. And it is tied into all the circuit boards as well, to where if it ever does fail, it's going to completely shut the unit down. It also has a float switch built into the system to where if that primary drain ever does get clogged up, it's going to trip that sensor and again, shut down the equipment. So we're not going to be able to have any issues with overflow. Also, the coil itself, we have sensors built onto the coil, so it's constantly monitoring that temperature. If it ever does get below that 32 degrees, which is when you're going to start getting into freezing issues, it's again going to back off that system, shut the unit down to where we can't freeze up any coils. It's just it's basically impossible to freeze these coils up.
So with this system here, obviously this would be a better unit, say for an attic space where you'd have access to it. So one thing that's important with a unit like this is to maintain access to it so
That is correct.
Devin can service it in the future if it ever needs it. So we're going to do a drop ceiling in this space here so that it'll be like a standard 2x2 grid ceiling so that we'll always have access to it, but the ceiling is going to look a lot better than having a big access panel there. So that's just something to keep in mind if someone's looking at a system like this.
That is correct. Because if you just look at the bottom of this unit here, we have to be able to access the entire bottom of it just to get to any coils, the fan motors, blower wheels, and then also we need at least about 6 to 8 inches on this side of the unit to get to the main circuit boards and all that stuff to be able to work on it. So with that being said, you just have to picture a huge access panel in here to be able to get to this system. So that's why we kind of more recommend leaning towards attics to put these units in. Or you want to go with a different design like we're going here, we're using a drop ceiling with the removable ceiling tiles.
So how's this mechanical room in terms of a scale of 1 to 10 of things that you've worked in before?
Well, I'm going to call it a 12.
Yes.
A beautiful mechanical room. And one of the biggest things when we knew that this was going to be an amazing space, even though nobody's going to be in here, maybe once a month or so, this is going to make you want to be in here. So as you look around now, we have the different style air handler again. This is actually 2 air handlers hanging on this platform. One air handler is taking care of the first floor, the second air handler is taking care of the second floor.
And why did we do that?
So now we're getting into zoning. Now a lot of times in the summertime we're going to have a lot of heat rising to the top of the house in the space. And so now that unit could be working on kind of maintaining that as the heat rises, we're going to be able to start cooling that. First floor, again, heat rises, first floor can now kind of modulate itself down, second floor could kind of take over, and vice versa for wintertime. Okay, now as you can see here, we ended up having a lot of size constraints on the house when everything was being built.
Whose fault is that?
That would be Derek.
Yes, it is.
So now what we did to be able to work with what we have here, to be able to get 2 systems in here, we just didn't have quite enough space going into the main house for our ductwork. So what we did was kind of a little bit out of the box, kind of a little bit different, is we actually put in an oversized duct return, and it actually comes in here, as you see with the sheet metal ducting, to a plenum itself. And then as you see at the top where we have the insulated ducting there, that's our takeoff for each return. So we have a 14-inch round return and also a 12-inch for the smaller air handler. I know everybody's going to start talking, well, now we're going to be backfeeding and drawing air from a different space. Well, what we did to eliminate any of those issues that could happen is we actually installed backdraft dampers. So now if one system is completely off, there's no way that it's going to be able to pull from the other zone.
And I highly, highly appreciate that they took a lot of time and effort to do their refrigerant lines really nice, and they even used strut in here, and it is looking gorgeous. And instead of doing a secondary drain pan under these units here, we just did some sheet metal on the platform here just to kind of eliminate having a drain pan here. One main reason being because if this were to leak, we've got a floor drain right there, and we'll be able to obviously see if there's any issues with it. So we just wanted to put some sheet metal on here just so it doesn't damage the plywood, and it'll just kind of pool off to the side. But this has also got a float switch in it as well there. So.
And again, this evap coil also has the sensors on it, so it's going to be constantly monitoring that temperature as well. So again, even with this style of air handler, we have no issues with any freezes up, stuff like that.
Money, money, man. And we've got Jim Clark, Mr. Mitsubishi himself, in this area.
Wow. Thank you, sir. I appreciate that.
He put on his nice shirt and his nice pants for us today, slicked his hair back. But he's going to talk to us about one of the main benefits of using Mitsubishi, and specifically their VRF system, and why it might be a good idea why you should integrate it into either a home build that you're doing, or maybe you've got a retrofit project that you want some better comfort.
So there's a million things that we can do, and I would drive you to look at our Mitsubishi .com site to look at all the different products that we have. But some of the things I want to talk about, really why Mitsubishi, and why would you ever think of our product in your home? And there's a lot of energy efficiency, why, but you know, one of the things is that we really strive to make our product perfect. And when I say that, I'm not just talking about, you know, R&D. When a product goes through R&D, we put it into the manufacturing floor. Most manufacturers will then, once it goes to manufacturing, will try to make it a lot more economical to build, and the Japanese do not do that. R&D is, you build it in R&D this way, you build it on the floor as well that way. And so some of the things that we do, and it helps with our warranty, is that when you look at manufacturers of HVAC equipment, usually you'll see about 6% of their gross sales is warranty. With ours, it's 0.002%. And of that 2%, a lot of it is actually install related. So critical on the install, you need to make sure you've got a Diamond contractor installing it. And you can find those guys on our site too, MitsubishiComfort.com. But let me go through again what happens at the factory with our product. So when we are manufacturing, whether we're doing our electronic boards, we're building them, we test them there. And then as we install it in the product, we test it again. Like our blower wheels on our fan coils, those are installed on the motor. It's tested then. And so as we go through our process, even our coils, they're all pressure tested to 600 psi, not nitrogen, helium. So that basically, because it's a smaller molecule, it gives you about 1,000 psi pressure test. So when we go through all that, and as we finish a fan coil and we get ready to box it up, we know that that thing has been run piece by piece and then as one complete part. And it had to go through a series of tests. The condensing units, the same thing. Everything's been tested all the way through the process, so it's perfect when it arrives at our consumer. We can't always handle all the freight damage sometimes. That's where we have a hiccup, but the only reason we pull equipment off the floor is to test it to make sure it's AHRI standards. Otherwise, we're not just picking to see if it's going to be, is this a good unit or not? So, do we lose compressors? No. Sometimes lightning takes us out. Sometimes the miswiring takes us out. And a lot of times refrigerant, low leak or slow leaks in our systems will take our compressor out.
I'm laughing because when I was wiring up a reefer once, and I miswired it, and I burnt the compressor, and it went back under warranty because we're basically like, we don't know what happened, but there's usually something else involved. And so that's one thing that, you know, Jim was telling me about their systems. It's like each unit that gets sent out is tested. It's not like you test one unit and then manufacture 100. You test every single one.
Absolutely.
Yeah.
Every single one, every time. And, you know, it's our, you know, dedication to the product that we want to pass on to the consumer. But we're also passing it on through our distribution plan as well. Our distributors, our contractors know that when they get the product, that nothing is going to be wrong with it. But obviously, you're going to meet some of the people today and why we do the things that we do. We have distribution that has what we call DSGs. You're going to meet Rick. He's a DSG locally with one of our distributors, and probably one of the sharpest guys with VRF in the country. We're very lucky to have him. But his job is to teach the contractors, to make sure they understand that the install process is very, very critical. So coming out to a job site, he didn't need to teach Williamsons anything, but it's good to just reinforce and explain why he's doing certain things different ways. And nothing's wrong other than we do want you to pressure test 600 psi. We want you to make sure the wire is correct. And but Anyways, let's talk about your house. I just absolutely love it.
This guy's loving it right here.
I do. I think this is so cool. And I look forward to moving in. The spare bedroom.
We got a spare bedroom up there.
Okay, see there's a lock on the door. But the thing is that you've got it zoned off. I would have probably have done it a few different ways, but there's no really wrong way to do it. You've got some ducted units, some of our great ducted units. We have the SEZ over here. Over, what you can't see, you'll probably see them later, is the SVZs as well. And of course, like I say, Williamson's done a fantastic job of installing it and getting your ductwork placed. It's not finished yet, folks, so stay tuned.
So you'll see, basically we're doing a lot of spiral exposed duct. So even when the drywallers came in here, they're like, the HVAC isn't done. And I'm like, it's done for drywall. So when you see that all finished, it's gonna look right on the money.
Of course, we haven't started it up yet today, so they're still, no, I'm just kidding. We've done diagnostics, we've done everything to make sure that as we get it started up, that everything's just gonna purr along.
So just some final thoughts on the HVAC system, guys. I think if you're gonna be building a house yourself or having someone build it for you, the first thing that you wanna obviously look at is building a well-insulated home. That's one reason why I love ICF and having a good passive solar design. That's where you want to start. The next best place to definitely put your money if you are wanting to improve the comfort of your home, and that is the HVAC system. So going with a very high performance, high efficiency, either mini split system or a VRF system, multi-zone system like we got going on is going to really improve the comfort inside of the home. And if you're going to be doing it, do it right from the get-go. Spend the money where it's going to matter the most to you. And if having a comfortable living space inside is very important to you, then a properly designed and sized HVAC system is going to be a great place to put your money, and having a multi-zone system so that you can only heat and cool the places that you actually want to heat and cool at the times that you want to do it, as opposed to having a very inefficient unitarian system. Going with a multi-zone system, especially for if you're planning on living off-grid or if you're going to be living on solar, these systems are far more energy efficient. They don't have huge kick-up amperage, and the instantaneous power is not nearly as much when you're using a VRF system like that. So you're going to pay for it once, but you're going to enjoy the benefits of it for the entire duration that you're going to be living in that space, and invest in those things that are going to make your life better, more comfortable, and so that you can enjoy it so much more. Awesome, guys. Thanks so much for watching. We'll catch you on the next video. Talk to you soon. Peace.